Hello friends, welcome to our channel. Today I am going to explain you the exercise 1.2 of the chapter 1 real numbers of the 10th standard mathematics SSC board Telangana and Andhra Pradesh. On to the exercise now. In the exercise 1.2, the first question is, express each of the following numbers as a product of its prime factors. So firstly, let us know what are prime numbers. Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. All these are prime numbers. What exactly are those prime numbers? Yes, prime numbers are those numbers for which the factors are either 1 or the same number. If you take for example 2, 2 is nothing but 1 into 2. Here you have 1 and the same number 2 only is there here. Okay. If we take 3, 3 is again 3 is in which table do we get 3? 3 ones are 3. That's all. Okay. So here if you see the factors, one is 1, other one is the same number 3 itself. Okay, so if you take 5, 5 is also 1 into 5, 5 and the same number, 7 also 1 and 7. Okay, other than that, there are no factors. Now, what are the other numbers? Yeah, the other numbers are called composite numbers. If you see 4, 4 is nothing but 2 into 1. Here 2 is a factor, 1 is a factor. So other than 4, there is some other factor. Okay, for other than 4 and 1, there is some other factor, that is 2. So this is a composite number. Here, what is the task given to us? Prime factors. Okay, so before we go into prime factorization, I'll just give a little bit of hints about the divisibility test. Which number is divisible by 2, which number is divisible by 3, and which number is divisible by 5, so that it will be easier for you to understand which one should you take, rather than dividing and coming to a conclusion. Looking at the number, you do a little bit of checking out and you will understand whether you should divide by 2 or 3 or 5. Okay, so firstly with the divisibility test of 2, if the last number is 0, 2, 4, 6 or 8, then it is divisible by 2. Okay, so in these numbers, if you see 140, last digit is 0, then it is divisible by 2. 156, last digit is 6, that's divisible by 2. Like that you have to check. 3825, last digit is 5. No, it is not divisible by 2. So we will go to 3. Okay, what is a divisibility test of 3? The divisibility test is you should add the digits 3 plus 6 plus 4. If suppose the number is given is 3642, you have to add the digits 3 plus 6 plus 4 plus 2. What will you get? 3 plus 6, 9, 9 plus 4, 13, 13 plus 2, 15. Is 15 divisible by 3? Yes. So this 3642 is also divisible by 3. Okay, and for the 5, if the last digit is either 0 or 5, either 0 or 5, that number is divisible by 5. Now look, for 2 also there is 0, 5 also there is 0. Which one to take? Yes, of course, the right choice is 2. First, you should come in the ascending order. First, to check with 2. If not divisible, then go to 3. If not divisible by 3, then go to 5. Don't rush up in a hurry and go with 5. There won't be an order. Of course, you can solve the problem, but it's always better to go in the ascending order. Okay, let's get into the exercise now. 140. The first question here is 140. The last digit is 0. It is divisible by 2. So 270 is a 140. If you take 70 again, last digit is 0. That's also divisible by 2. So 2, if we divide, we get 35. 235 is a 70. Now 35. The last digit is 5. Okay, so what's our right choice? Yes, 5 is the right choice. 5 sevens are 35. 7 ones are 7. 140 is equal to 2 into 2 into 5 into 7. 2 into 2 into 5 into 7. So how many 2's are there here? There are 2 2's. So how will you write that? 2 square. How many our 2's are there? That many. Okay. So if it is 2 into 2 into 2, you will write it as 2 cube. Okay. Here 2 2's are there. So 2 square into 5 into 7. That is the answer. Yeah. We move on to the next one. 156. 156, if you see, the last digit is 6. 6 is divisible by 2. Therefore, we will do with 2. 156 divided by 2, you get 78. Okay, if you see 78, last digit again 8. This is also divisible by 2. So again, if you divide 78 by 2, you get 39. Okay, 39. 9 is not divisible by 2. So you have to try with 3. If you go for 3, 3 plus 9 is 12. Okay, 3 plus 9, 12. So if 12 is 12 divisible by 3, yes. So 39 is also divisible by 3. Okay, 3 13s are 39. Okay, 13, you know, as such it is a prime number. Okay, it's not divisible by any other number. So you can write it as 156 equal to 2 into 2 into 3 into 13. So how many 2's are there? 2 2's are there. So 2 square into 3 into 13. Okay, right. We move on to the next one. That is 3825. If you see 3825, what is the last digit? Last digit is 5. Okay, so it is not divisible by 2. So we will go with 3. Let's add 3 plus 8 plus 2 plus 5. 3 plus 8, 11. 11 plus 2, 13. 13 plus 5, 18. Is 18 divisible by 3? Yes. So we can divide this by 3. So when we divide 3825 by 3, we get 1275. Again add the digits. 1275. 1 plus 2 plus 7 plus 5. 1 plus 2, 3. 3 plus 7, 10. 10 plus 5, 15. Is 15 divisible by 3? Yes. So this is number also is divisible by 3. So 3. 3 is 4, 2, 5. Okay. And then 4 plus 2 plus 5. If we add and see. 4 plus 2 plus 5. 4 plus 2, 6. 6 plus 5 is 11. This is not divisible by 3. So we will go with 5 because the last digit is 5. Okay. So if we divide by 5, 425 divided by 5, we get 85. Okay. Again 85. If you see 8 plus 5, is it divisible by 3? Not divisible. So we will go with 5 again because the last digit is 5. 5 17s are 85 and 17 is a prime number, you all know, so we cannot do anything. Okay, so if we write the prime factors, of 3825, how will you write the prime factors of 3825? 3825 is equal to 3 into 3 into 5 into 5 into 17. 3 into 3 into 5 into 5 into 17. 3 into 3, we'll write it as 3 square. 5 into 5, we'll write it as 5 square. Yeah, into 17. Okay, we move on to the next sum. We move on to the next sum, 5005. Okay, 5005, last digit is 5, so it is not divisible by 2. Okay, so last digit is 5, it's not divisible by 2. Now, if we go with 3, 5 plus 5 is 10. That's also not divisible by 3. Okay, so last digit is 5, so you can go with 5. If we divide 5005 by 5, we will give 1001. Okay, and 1001, is it divisible by 2? No, it is not. 1 plus 1, 2. That's also not divisible by 3 also. Last digit is 1, so not divisible by 5 also. What is the next prime number? Yes, it is 7. Okay, if you try with 7, you'll get 143. 1001 by 7 will give you 143. So 143, again divisible by 2? No. Divisible by 3? No. Divisible by 5? No. Divisible by 7? No. Then what's the next prime number? It's 11. So if you divide 143 by 11, you get 13. Okay, 13 is a prime number. So there are no other factors. 13 ones are 13. So here if you see 5005, there is no repetition. One is 5, 7, 11, 30. So there are no squares or cubes. 5 into 7 into 11 into 13. Okay, we move on to the next one. 7429. 7429, if you see, what's the last digit? Last digit is 9. So it's not divisible by 2. If we add 7 plus 4 plus 2 plus 9. What will you get? 7 plus 4, 11. 11 plus 2, 13. 13 plus 9, 22. 22 not divisible by 3. So not divisible by 3. Then if we go to 5. Last digit is not 5 or 0, so it's not divisible by 5. Then the next is 7. 7 also not divisible. Then 11 not divisible, 13 not divisible. So we go with 17. Okay, if we divide 7, 4, 2, 9. For 11, 13 and all, you have to divide. And 11, of course, there is a divisibility test, but it's a very long one. So it's better that we divide, because 11 table is very easy. 11, 22, 33, 44. So like that, it's easy to divide. Okay, and then we go with 13, you have to divide and see. Then we go with 17. When we divide 7, 4, 2, 9 by 17, we get 437. Again, 437 not divisible by 2, 3, 5, 7, 11, 13, 17. So we go with the next choice, that is 19. So if we divide 437 by 19, we get 23. So 23 is a prime number. So 23 ones are 23. 7429 is equal to 17 into 19 into 23. As there are no repetitions, we write the factors as it is. Okay. We move on to the next question. Find the LCM and HCF of the following integers by prime factorization method. If we go with the HCF, for the HCFs, we will write only the common ones. Only the common factors we write. Okay, only the common ones we will write. For LCM, what we do is, first we take common. Okay, then whatever is remaining, that also will multiply. That is the LCM. Okay, that is the difference between HCF and LCM. Okay, so we will go about it here. The first question is, find the HCF and LCM of 12, 15 and 21. Okay, 12, 15 and 21. Okay, so if you can do it combined this way, that's also okay. So if you find it difficult, you can do it separately also. For 12, you can do separately. For 15, you can do separately. Okay, 2 6 are 12. 2 3 are 6. 3 1 are. Okay, for 15, again, you can do it. 3 5 are 5 1 are. Okay, and then for 21, you can do it separately. If you can do all together, then that's fine. But if you can't do it, then do it separately. Okay, so here you can do it separately and write down the factors like this. Or you can do all at a stretch. How do you do all at a stretch? Is firstly take 2. Whichever is divisible. 2 6 are 12. Okay. 15 not divisible by 2. You write the 15 as it is. You don't do anything. You just write it as it is. Then 21. 21 not divisible by 2. No. You write it as it is. Okay. Then we go with 2 again, because 6 is divisible by 2. Okay. So 2. 2 3s are 6. And 15, 21 not divisible. So write them as it is in the next step also. Then we go with 3, because here no number is divisible by 2. So we go to the next choice, 3. 3 1s are 3. Yeah. Now these two are divisible by 3. So do the division now. 3 5s are 15. 3 7s are 21. Okay. Next. Now it's not divisible by 2, or you should see all the numbers. First choice is 2. Second choice is 3. Then third choice is 5. Let's see what is anything divisible by 5? Yes, it is. So 5 1s are 5. The one as it is, you'll get it down. Okay. 5 1s are 5. 7 not divisible by 5. So 7 you write as it is. Okay. Now 5 is over. Is anything divisible by 5 still? No. So we go to the next choice, that is 7. 7. This one as it is, you get it down. This one also as it is, get it down. 7 1s are 7. Now you have to write the prime factors. 12 equal to 2 into 2 into 3. That means till where we did it into 1. By the time the 12 became 1, it is 2 into 3. Okay. For 15, when did we start dividing the 15? From this step. So this is 3 into 5. Okay. And then 21. From where we started dividing? From this step. 3 into 7. Okay. So after that, we have to go first with the HCF. HCF, what is the common one here? Common one is 3 here, 3 here, 3 here. So HCF is 3. Only common one you write in HCF. In LCM, what do you do? Firstly, you write the common one. What is the common one here? 3. Okay, LCM, you will write the common one. What is the common one? 3. Okay, and after that, what is remaining here? 2 square. Okay, 2 square into, here what is remaining? 5 into, here what is remaining? 7. First write the common one first, then write whatever is remaining. Okay, so here you can write it as 3 into 4, 12 into 5 into 7, 35, which is nothing but 420. Okay, so that way you have to write. We will go with the next one. The next one is 17, 23 and 29. Okay, so 17, how will you write? 17 is a prime number. So 17 ones are 17. Okay, so write the 23 and 29 as it is. Then 23 is also a prime number. So 23 ones are 23. So it is again, you will write it as it is, the 29 down. Again 29 also a prime number. So 29 ones are 29. All 1 has come. So now we have to go with the HCF. What is common here in all of them? Is there any common thing? So nothing is common. You will write it as 1. Because if you write 17, it is 17 into 1. Okay, 23, you'll write 23 into 1. 29, you'll write as 29 into 1. 1 ones are 1. 1 ones are 1. 1 ones are 1. So if you write it separately like this, 17 into 1. 23 equal to 23 into 1. 29 equal to 29 into 1. So what is a common thing here? 1. Therefore, HCF equal to 1. Okay. If there is no number common, then you take the HCF as 1. Okay. Then we go to the LCM. Is there anything common? Firstly, to write it, that is just 1. Okay. And into 17 into 23 into 29. So the number that you get is 11339. That is 11,339. Okay. So we move on to the next one. The next numbers are 8, 9 and 25. Okay. So here if you factorize 8, you get 2 into 2 into 2. That is 2 cube. We factorize 9. You get 3 into 3, 3 square. We factorize 25. You get 5 into 5, 5 square. So the HCF, what is the HCF here? What is common in 3 of them? Is 2 common? No. Is 3 common? No. Is 5 common? No. So what is a HCF? As I told you, when nothing is common, you take HCF as 1. As I told you in the before sum, if you factorize them separately, everything comes like into 1, into 1. We say 8, 8 equal to 2 into 2 into 1. 9 equal to 3 into 3 into 1. 25 equal to 5 into 5 into 1. So if you see the common one, that is 1. That is HCF is 1. If you see the LCM, first take common. Nothing is common. So you'll multiply all of them. 2 cube into 3 square into 5 square. Okay, what do you get? That is 1800. Okay, we go to the next one. 72 and 108. If you factorize 72, you get 2 cube into 3 square. If you factorize 108, you get 2 square into 3 cube. Okay, if you see what is common in both of them for HCF, if you see what is common, here it is 2 cube. That is 72 equal to 2 into 2 into 2 into 3 into 3. Okay, 108 equal to 2 into 2 into 3 into 3 into 3. So if you say take the HCF, only take the common ones. 2. Okay, here also 2. Yeah, and we can do like this also if that method is confusing. 3. Okay, so and this, so into 3. Okay, so our HCF is 2 into 2, 4. 4 3s are 12. 12 3s are 36. Our HCF is 36. Okay, so LCM is 2 cube into 3 cube. That is here 2 cube. Okay, that is here 2 square is common. So here if you see here, we have taken what is remaining. Remaining is LCM. If you see, common is 36. Okay, what is remaining here without rounding off? This 2 is left, this 3 is left. Okay, 36 into 2 into 3, that will give you 216. That is our LCM. Okay, you can do either of the ways, whichever is easier for you, that way you can choose. Okay, and then going to 306 and 657. If you factorize 306, you get 2 into 3 into 3, that is 3 square into 17. If you factorize 657, you get 3 square into 73. If you see what is common in both of them, that is 3 square. So our HCF is 3 square, which is nothing but 9. Okay, LCM. Firstly, take the common one. What is common? 3 square. And after that, what is remaining? 3 LCM equal to 3 square. The common one we will take. What is remaining? 3 square into 2 into 17 into 73, which will give you 22338. That is 22,338. Okay, we'll move on to the next one. Here we have the question number 3. Check whether 6 power n can end with the digit 0 for any natural number m. Okay, here we are given 6 power n. 6, if you factorize 6, you get 2 into 3 power n. If the last digit must be 0, it should be 2 into 5. 2 5s are 10. 10 power n only you will get the digit 0. Okay, for 10 square only you will get 100. Yeah, so it should 2 should also be there, 5 should also be there. Then only you will get the last digit 0. But here what do we have? We have 2 is there, of course. But do we have 5? No. So there are no possibilities of getting the last digit as 0. So here is the explanation. The given number is 6 power n, which is equal to 2 into 3 whole power n. The prime factors here are 2 and 3 only. Okay, to end with 0, 6 power n should have a prime factor of 5 and also 2. But here there is no 5 here. There is only 3. 2 and 3. So it is not possible. So 6 power n cannot end with 0. Okay. So we go to the next question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay, let's come. So what will we do? Firstly, one by one also you can do, or both together also you can do. Okay, firstly we will go with first one. 7 into 11 into 13 plus 13. This symbol you should be careful. Okay, so if we go like this, what is the common thing here? Yeah, 13 is common. We will take it out. Divisibility rule. Okay, 13 is common. We will take it out. This side plus. Okay, this side what do we have? This side of plus is one division. This side of plus is another division. Okay, you took common. Here also 13. Here also 13 is there. You put the 13 outside common. What is there here? 7 into 11 plus. That side of 13, what do we have? 13, which is nothing but 13 ones are 13. Okay, so as it is multiplied by 13 into some other number, that is not the same number and 1. Other than 1 and the same number, we have other factors. Therefore, it is a composite number. Okay, we go to the next one. What is the next one? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Again divide. This side of the plus symbol is 1. This side of the plus symbol is another. What is the common between both of them? Yeah, this side and that side. This is one side. You have to assume it this way. Then writing in divisibility rule will be easy. In this side and this side, what is common? Yes, 5 is common. We take it out. 7 into 6 into 4 into 3 into 2. 1, we can ignore the 1. 5 ones are 5. Okay. So we can ignore it. And then this side, what is there? 5, which is nothing but. Okay. So here you have it this way. Okay. So if you write it like that, you will get it like this. 13 into k, that is 13 into something. And 5 into something. Okay, that is, you can write it as K, L, or any other letters also. Okay, so as you are writing it with other things other than the same number and 1, they are all composite numbers. As the given numbers can be written as a product of two numbers, they are composite numbers. Okay, we move on to the next one. How will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? So if you see here, 17 into 11 into 2. Okay, this is 1 plus 17 into 11 into 5. This is 1. If you see what is common here, you take 17 into 11. Both are common here. Here also 17 into 11. Here also 17 into 11. Okay, we take it out. Okay, here what is remaining? 2. And there what is remaining? 5. So if you write it like that, 17 into 11. What do you get? 187 into, okay, 2 plus 5 is 7. Okay, 187 into 7. They are written as a product of two numbers. Therefore, it is a composite number. Next question is, what is the last digit of 6 to the power of 100? So if you see, let's check. 6 to the power of 1 is 6. 6 square is 36. 6 cube is 216. 6 power 4 is 1296. 6 power 5 is the 7776, that is 7776. So if you see, the last digit is always consistently it is 6 only. Okay, so we can conclude that 6 to the power of 100 will also be 6 only. There are no changes at all. Everywhere you are getting the last digit as 6. So we see that 6 power n, for any positive integer n ends in 6. Unit digit is always 6. So we can conclude that unit digit of 6 power 100 will also be 6. Hope this session was useful to you all, and hope I could help a bit to understand the things in a better way. If this session was useful to you, please click the like button. Your valuable comments are always welcome. Kindly subscribe our channel. I will update you with the further exercises of the textbook with the other possible learning ways. Thank you for watching and have a wonderful day. Kindly subscribe.